Hello everyone, my name is Josh and welcome to today's videos on function notation. So function notation is a concept in maths where you're given I don't know how else to explain it, but so you've got an equation which we'll call a function, and a function is anything that does something to a value. So like we generally give it the notation f of x is equal to something. So let's just say, make one up, x squared plus 3. So in order for a function to happen, it takes a value and does something to it. It doesn't matter what it does, it just does something. So in this case, you've got the name of your function is f. X in the brackets is it's a function of this variable. And then you've got the actual function itself defined. So you can have a function of anything you like. So you can have g of y equals y cubed minus y squared. All it means is this is the name of the function, this is the variable involved with it, and this is the function definition. So you can do lots of different things with functions. The first thing I'm going to focus on doing is evaluating functions. So evaluating. So in order to evaluate a function, basically all it means is to take a value and find out what the function is equal to at that value. So for example, we can take a function, let's say f of x equals x over x plus 2. Now we want to evaluate this at x is equal to, I don't know, let's say 3. So to evaluate x equals 3, all we do, in our notation, we say f, and now x is equal to 3. So all we do is take that 3 and put it in there. So f of 3 is equal to, and then we take this x equals 3 and put it into here. So we just substitute all of the x's out for 3's. So f of 3 is equal to 3 over 3 plus 2. And that equals 3/5. And that's it. Evaluating functions is quite a simple process. All you want to do is it'll give you a value either in the format substitute in x equals a number, so 2, or it'll give you it in the format of f of 2, which both mean the same thing. You just take your x value and replace it with 2, both in the definition and in the labeling at the start. So we'll do it for another function just to have a little more of a look. So we'll say g of x is equal to x squared minus 2. And we'll evaluate this function at x equals 5. So for this function, what we do, take that x, sub it in here, so we get g of 5 equals, now we take this x, sub it in here, 5 squared minus 2 equals 25 minus 2, and that equals to 23. And that's the function evaluated at that value. So this is quite a quick, simple process. Once you've done it a few times with a couple of different functions, you get the hang of it and know what you're doing. You can just make up any function you want, try and put your value in, and see what happens. Like, it should always just come out to something correct as long as you substitute your numbers in correctly. So that's evaluating functions. The next thing I'm going to talk to you about is composite functions. Now, composite functions, let me just write it down. Composite. So a composite function is basically where you've got two functions defined and you merge them together to make one function. So for example, we will take the two functions that we had before, we've got f of x equals x over x plus 2, and g of x equals to x squared minus 2 from before. So a composite function can have loads of different forms of the notation. So they might give you one in this form, where you've got fg of x, or they might give you it with an extra bracket in, f of g of x, like that. This is my favourite way to write it. If I'm using my own notation, this is the way I'll use it, because it's easy to see, because this looks like f times g, but it's not multiplied. It's substitute g into f of x. So this way it's easier to see, because it's just like when we were substituting in like x equals 3 before, but this time we're substituting in x is equal to g of x, and in this case g of x is equal to x squared minus 2. So say we want to find the composite function f of g of x. So f of g of x is equal to substituting g of x into f of x. So what we do is, like before, we now write this as f of, so g of x is x squared minus 2. So here we put x squared minus 2 is equal to, now as before, in our function definition, when we substituted in the value, we just swapped all of the x's for whatever the value was. Well, this time, we're doing it, swapping the x's out for whatever the composite function is. So here we've got x squared minus 2, so that means every x should go to x squared minus 2. So we put this in, and we get x squared minus 2 over x squared minus 2 plus 2. See, it's just a simple process. All we've done is taken this and put it in everywhere where there's an x. So we can now simplify this down. So we have x squared minus 2 over x squared minus 2 plus 2. Those two cancel out. So we get x squared minus 2 over x squared. And that you can simplify again is to 1 minus 2 over x squared. And this also you can write in a slightly different format to just be 1 minus 2x, right, I need to, 2x to the minus 2. This is just a indices law, which if you're unsure about, just ask me, and I can cover indices if people are confused by that. But basically 1 over x squared is equal to x to the minus 2. So if you're told to give it in a format such as a plus b x to the n, that's how you do it for this case, 1 minus 2x to the minus 2. Or 1 minus 2 over x squared, if that is the format that they want you to give the answer in. Now, one thing you'll often find is f of g of x is not usually equal to g of f of x. So it matters which way round you do this. You have to be sure to do it the right way, because most of the time it will give you a different answer. There are, of course, exceptions. Sometimes it still works out to be the same, but not often. So just to prove this point, I'll also do g of f of x. So in this case, that means we want g of x over x plus 2. Okay, so to take the composite of g of f of x, we get g of x over x plus 2, and that would be equal to, so we just sub x over x plus 2 into here, so that's x over x plus 2 all squared minus 2, because this is an x squared, so we have to square all of this. And that is equal to x squared over x plus 2 squared minus 2. Yeah, and so that's just equal to x squared over x plus 2 squared minus 2. Now, as you can see, this is a different answer to what we got for f of g of x, which is why I say this rule is very important. Always make sure you know which way around you're doing this. The way to know is whatever function is on the inside, that is what you're substituting in, and the one that's on the outside is the function that is having something put into it. So you use whatever function is on the outside and put the inside one into the outside one. So that's how you do composite functions. You just need to substitute in one function for another and make sure you do it the right way around. So the final thing about functions I will go through is inverse functions. So for an inverse function, we basically want to do the opposite of what the function is doing, such that, say for example, we have a function f of 2 equals 6. Like, this is once you've substituted everything in, you find f of 2 is equal to 6. Well, when you do an inverse, you want to show that f of 6, actually, I'll call this differently. So you want to show that our inverse of this function, f to the minus 1 of 6, is equal to 2. So it just wants to reverse whatever operation you've performed. So if we take the function from before, g of x is equal to x squared, that's horrible, x squared minus 2. The way we take an inverse function is we set whatever our function is, we'll call that y. Or if you've got a function in terms of y instead of x, then just call it something else. It just has to be a variable that we've not used already. So we'll say this is now y equals x squared minus 2. So what we want to do is rearrange to get x equals something. So we want to get x from this. So what we do is rearrange this. So y plus 2 is equal to x squared. And so x is equal to the square root of y plus 2. Just going to make that plus a bit more obvious. Y plus 2. Okay, and so the next step, once you've got something equal to x, you want to swap out. So now that you've done that, you swap your x for f to the minus 1 of x, and swap y for x. So this seems a little bizarre step, but basically all we're supposed to do, the first thing we'll do is swap x in this equation for f to the minus 1 of x. So, sorry, in this case, because we're using g of x, we'll say g to the minus 1 of x is equal to, and now we swap our y's for x's, so it's x plus 2 square rooted. So all we've done is swap x in this for our new inverse function, and y for x. So this is what we come out with. So if we substitute in to test if our inverse worked, we'll try g of, I don't know, let's say 5. G of 5 equals 5 squared minus 2, which equals 23. So doing g of 5 equals 23. So if we put this 23 into g to the minus 1 of x, so g to the minus 1 of g to the minus 1 of 23, we get 23 plus 2 square rooted, which equals 5. So you see, we've managed to do the exact opposite of what the original function did, because we took its answer, put it back in, and got back to what we substituted in. So that means that our inverse function is correct. So this is the final answer. So this isn't a necessary step unless it tells you to prove that it's an inverse. But this is always a useful step to do to check that your inverse function has worked properly. So that's all there is to do in it. You just swap out your function for y, rearrange it to get something x equals to something, swap the x for f to the minus 1 of x, or whatever function label you're using, and then swap y for x. So that just goes to f to the minus 1 x, and that just goes to x for when you're doing it. So that's all there is to inverse functions. I'm going to show you you can also take an inverse of a composite function. So for example, if we take the composite function we had earlier, which was f of g of x is equal to 1 minus 2 over x squared. So what we'll do is follow the exact same procedure as before. We'll swap this out for y. So y equals 1 minus 2 over x squared. And we want to rearrange to get something in terms of x. So we do 2 over x squared equals 1 minus y. Just adding that and subtracting that. Then we do 2 equals 1 minus y in brackets times x squared. Divide through, so we get x squared equals 2 over 1 minus y. And then we square root, so x equals the square root of 2 over 1 minus y. So now, using the same thing that we said before, we swap this out for f of g of x to the minus 1, because we're just doing the inverse of whatever it is we were given. And we swap this out for x. So doing that, we get f of g of x to the minus 1 is equal to 2 over 1 minus x square rooted. Let's just make that square root a little bit neater. Square rooted. So again, that's our final answer, but if we just want to check it, we'll substitute in a value. So let's say, if we take, for example, x equals 1, and we substitute this into f of g of x, so f of g of 1 is equal to 1 minus 2 over 1 squared, which equals minus 1. So if we substitute minus 1 back into this inverse that we found, we should get back out to 1. So we'll try it. F of g of minus 1 all to the minus 1 equals 2 over 1 minus minus 1 square rooted, which equals square root of 2 over 2, which equals square root 1, which equals 1. So as you can see, we've managed to get back to the 1 that we substituted initially, and that means that our inverse is correct. So those are just an example of some of the types of questions you may be given on functions in terms of finding out, evaluating composites and inverses. These methods all hold for whatever functions you're given, so you should now be able to attempt any of those methods from questions online, and you should be able to solve them using these techniques. If you find that there are any that you're struggling with and you can't seem to grasp the solution, then just contact me and I'll help you through with them when I can. That's it for today's video. Thank you for watching. I hope you found this helpful. If you have any topics that you'd like me to cover, as usual, just contact me somehow and let me know what it is, and I'll make a video on it when I get time. And yeah, as always, if you're stuck on anything, just let me know and I will try and explain it when I get the chance to try and help you along. Thanks again for watching this video, and I hope to see you next time.